Okay, so let's take a look at 4.1, the vertex form of a quadratic function. It says here the vertex form of a quadratic function is written like this: f at x function notation equals a x minus h plus squared plus k. You know that hk is your vertex. You also know that h is your equation of your axis of symmetry. Okay, and based upon whether the a value is positive or negative, if it opens up or opens down, that will tell you if there's a max or min. If the equation opens down, if the parabola opens down, you will have a maximum point. But if the parabola opens up and goes forever up, you will have a minimum point. So this is definitely going to deal with a lot of maxes and mins this unit. So example 1, it says, for the quadratic function f at x equals 2, x minus 2 squared minus 3, determine the direction of the opening, so that's the first thing, the equation of the axis of symmetry, the vertex, and whether the parabola will have a min or max, and what the value of the min or max is. Sketch the graph using the above information and 2 other points. State the domain and the range. So if we take a look at our a value is 2, our h value is not negative 2 but positive 2, and our k value is negative 3. So we definitely know that this parabola opens up because the a value is 2. Then, the equation of the axis of symmetry, we know that the equation of the axis of symmetry is always x equals, and whatever my h is, in this case it's x equals 2. That is not the x-intercept, it's the equation of the axis of symmetry, where the vertex lies. The vertex of this thing is hk, so that's 2, negative 3. And then, does this thing have a max or a min? Well, if this thing opens up, then it's going to have a minimum value, so a minimum of, and it's always a minimum of your height. So in this case it will be a minimum of negative 3. It asks me to sketch the graph using the above information and 2 other points and state the domain and range. So the easiest way to come up with a table of values for this scenario, in this case f at x equals positive 2, x minus 2 all squared minus 3, the easiest way to come up with 5 points, well, the first point you know is 2, negative 3. That's the vertex. For sure you know this. Now, the easiest way to come up with 2 other points is that you know a parabola is perfectly symmetrical on the vertex. So whatever happens to the heights on the left of the vertex is the same as the right of the vertex. So I'm going to pick 2 points to the left, which is 0 and 1, and 2 points to the right, which is 3 and 4. And what I'm going to do is I'm going to figure out what my y value is when x is 0, and what my y value is when x is 1. And whatever those y values are on the left, those are the same as on the right because it's perfectly symmetrical. So I'm going to find f of 0 first. So f of 0 is just going to be equal to 2. X is 0 minus 2 all squared, and then minus 3. So f of 0 is going to be equal to 2. This is going to be negative 2 all squared minus 3. And so f of 0, please make sure you do the negative 2 squared first. So 2 times 4 minus 3. So f of 0 is going to be equal to 8 minus 3, which is equal to 5. So when x is 0, you know that y is 5. That means on this side, when x is 4, y is also equal to 5. You don't even have to check that. And then I'm going to find also f of 1. So I'm going to find that over here. F of 1 is going to be equal to 2 times x is 1 minus 2 all squared minus 3, And so f of 1 is going to be equal to 2. This minus this is negative 1 all squared minus 3. So f of 1, I'm going to do the negative 1 squared first, which is 1 minus 3. So f of 1 is going to be equal to 2 minus 3, which is negative 1. So I know when x is 1, y is negative 1. That means when x is 3, y is also negative 1. On both sides of the parabola, of both sides of the vertex, it is perfectly symmetrical. Now I can use these points in order to come up with the picture of this. So I'm going to label 2, negative 3 first. So I have 2, negative 3 right there. My next point, 1, negative 1, which is right there, I also have 3, negative 1. I have 0, 5, and I also have 4, 5, which is right there. And of course, if I graph this, this is my function of f at x equals 2, x minus 2 minus 3. And coming up with the domain and the range of this thing. So the domain, we've done this before, it's the set notation. Domain of this thing, domain of any parabola, unless it's a real life scenario where there's a start and a stop, is x is an element of all real numbers because it goes forever to the left and to the right. The range is going to be y is an element of all real numbers where, in this case, the lowest value that y is negative 3. So it hits negative 3 and everything above it. How do you write that? Where y is greater than and equal to negative 3. So that's problem number 1. Let's take a look at example number 2. Example number 2 says for the quadratic function f at x equals x minus 7 squared minus 16, write the function in standard form. Then it says determine the zeros of the equation. Okay, so method 1 is using expanding and factoring. We're actually not going to look at this method number 2 right now, but let's take a look at this. So coming up with this in standard form. So f at x is equal to x minus 7 all squared minus 16. How do we come up with this in standard form? Well, we have to expand this. Just remember how to expand x minus 7 all squared. That really means x minus 7 times another x minus 7. Now, of course, there's a shortcut to doing this, but if you don't remember the shortcut, please make sure that you do this the long way, because you should end up with a perfect square trinomial. So, continuing this, squaring this, I'm going to have x squared, which is x squared. The last term is going to be negative 7 squared, which is positive 49. And then the middle term is going to be negative 7 times x, which is negative 7x, double it, which is negative 14x. That ends up being a perfect square trinomial. And you still have the negative 16 kicking beside there. Okay, so you have f at x is equal to x squared minus 14x, and then you have 49 minus 16, which is positive 33. So this is the function in standard form after you expand it. Now, what we learned last unit is if we are given a function in standard form and we're trying to figure out the zeros, figuring out the zeros is figuring out the x-intercepts, and x-intercepts happen when y is equal to 0. So if we solve this, x squared minus 14x plus 33, this exact thing when y is equal to 0, we can solve this by factoring. And in this case, this is a simple trinomial. The product is 33. The sum is negative 14. So you're looking for two numbers that multiply to negative 13. Sorry, positive 33, but add to negative 14. The two numbers are negative 3 and negative 11. That times that is that. That plus that is that. So you end up with the first factor of x minus 3 and the second factor of x minus 11. Now, from the zero product property, what makes this bracket 0 and what makes this bracket 0? Well, when x minus 3 is equal to 0, that means x is equal to positive 3 when you bring that over. And when x minus 11 is equal to 0, that means x is equal to, bring this over, positive 11. So my two zeros are 3 and 11. Now, actually, I'm going to take a look at number 2, method number 2, and it says use inverse operations in order to come up with the x-intercepts. So another way to come up with the x-intercepts is by using this formula that is in vertex form. So if we were trying to figure out what the zeros are of a parabola that's in vertex form, we would do the exact same thing. The zeros happen, x-intercepts happen when y is equal to 0. So that's what I'm going to write here. 0 is equal to, and then I have x minus 7 squared, and then minus 16. That's exactly what's over there. Okay? Solving when y is equal to 0. Now, solving this algebraically is what this should say, inverse operations or algebraically. I'm going to first I'm going to solve for x, so I'm going to bring the negative 16 over here to become positive 16. This is x minus 7 all squared. And then in order to solve for x, I'm going to have to get rid of the square. So how do you get rid of a square? Take the square root. Now, taking the square root gets rid of the square, so I'm left with x minus 7 on this side. However, when you take the square root of 16, you would think that the answer is 4. And you're actually right, half right, because 4 times itself is 16. So yes, positive 4 is the square root of 16. However, negative 4 is also an answer because negative 4 times negative 4 is also positive 16. So the square root of 16 is actually plus or minus 4. So you got to remember that. So you end up with two answers because then you'll have x equals plus or minus 4. And if I bring this 7 over, plus 7. And you'll have to split this up into two different answers. You're going to have x equals positive 4 plus 7. And so you'll get 11. Or you'll have x equals negative 4